Okay, so I want to do this problem which says I want to calculate using Stokes a circulation. So a circulation is one of these of a vector field G. So calculate a circulation around a square. Oh God, corners. So the corners are 0, 3, 3, then 0, negative 3, 3, then 0, negative 3, negative 3, then 0, 3, negative 3, and then where? Back to the beginning, right? Is that 4 corners?
Yes.
Cool. Squares have 4 corners. This probably is still a square.
And it's all on the YZ plane too.
Oh, why? Yeah, so look at this. Notice x is 0, right? X is 0, that means that this is in the YZ plane.
Okay, we're not dealing with some weird parallelogram.
Yeah. Square, YZ plane. This could not be much chiller, right? Okay, so picture. YZ plane is which one?
Yeah.
Good answer. That one. So I need to go, what, back 3, up 3, whatever's, right?
Just pick 4 corners.
Okay. Back 3, up 3. Out 3, up 3. Down 3, out 3. Down 3, back 3. Okay, there's your square.
Congratulations, you made a target.
And it's oriented in counterclockwise. Oh, hey, that's cool.
Starts at the top right corner. So
Why is counterclockwise cool?
it's what we need to use Stokes.
Yeah, because I need to match the normal vector, right? What normal vector? I'm doing a circulation. What the hell? All right, seriously?
We know it's counterclockwise because it says oriented in that order. That's what it means.
So I would have to spend a second. So this says start at 3, 3, right? So this point up here is first.
Then we go to the y.
And then second is negative y's, positive z's, right? So that's this corner. So to go from first to second takes that way. And then if I'm looking at this picture, I'm like, okay, that way. And then the next thing is down in the z's, right? So this point down here is 3, and this point's 4.
What happens if we
So-
swap the ends?
That seems like counterclockwise.
Yeah, because it said oriented in that order, but it didn't actually say that it was like circulating counterclockwise.
Yeah, so the reason that I think it goes around, right, is that they told me to calculate a circulation around a square.
Yeah.
And then they gave me 4 corners in an order. But they didn't tell me this last, right, that the last one goes back to the first, but they told me it was a square and a circulation integral. So that tells me it's got to be a closed curve. You guys all good with that?
Going down the white rabbit hole, what happens if we accidentally switch those two?
Yeah, so if 2 of them are switched, then you're SOL on using Stokes. You guys see that?
Because it's no longer simple if it crosses, right?
Yeah, so it turns into like a jagged tine.
It's got to have a uniform orientation, right? And that orientation has to right-hand rule match the orientation of the surface for Stokes. And if you don't have a uniform orientation, you sure as heck can't right-hand rule it. You guys see that?
Okay.
It wouldn't be a circulation integral anymore anyway. You'd have to piece it out into the chunks and then do each piece separately.
With an extra chunk in the center because it's now an hourglass.
Oh, yeah. It would be, yeah, it might screw lots of stuff up. Okay. Anyway, point is, what does Stokes say?
that if we meet all the themes of counterclockwise, piecewise, smooth.
Okay. If stuff, then
Then
stuff.
the circulation of a vector becomes the surface area of the curl of the vector, basically.
So the circulation of a vector field around the edge of something becomes the surface integral of the curl, right? Okay, so what the heck is the surface here?
Curl.
Thank you.
Curl.
That would be our the square dy dz of 0 to -3 to 3, -3 to 3.
You guys see that? So I need this square filled in, right, is now my surface. So what do I need to apply Stokes here?
The stuff that allows you to.
Yeah, so I need to check everything, or I should check everything. They told me to use Stokes, so it probably is okay. But what would I be checking?
Counterclockwise, piecewise, smooth, simple, closed, bounded.
Bounded,
It's
partials
yeah,
or continuous, right? On some slightly puffier thing. But all that stuff is, oh, where did my G go? I didn't tell you what G was.
Yeah, no, you did.
Oh.
X, Y, comma, Z, comma, 3Y.
G was x, y, comma, z, comma, 3y. Okay, so what do I need to do?
Find the curl of G and then the area.
Cool. So let's take the curl. How do you calculate curl?
It's 3 to 1, 3 to 1. It's the shortcut.
Oh, let's do the shortcut. That's a great idea. So curl of G is, so G Z, G Y, G X, G Z, G Y, G X. Partial, 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 over, minus, 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 and then Y, Z, Z, X, X, Y. Remember how I said memorizing the bottom was dumb? It's actually really convenient.
Yeah.
Okay, so I lied. Sorry. Okay, so now I need the y partial of GZ. 3. Minus the z partial of GY.
1.
1. And then I need the the z partial of x. 0. And the x partial of the z component?
0.
Also 0. And the x partial of the y component? 0. And the y partial of the x component?
Okay.
X. So all told out of this, I got 2, 0, negative x. That's convenient. Right? Okay. Where did I lose you guys?
No, we're wondering if this was a quiz.
Yeah,
Reminds
this
us of the quiz familiar.
Yeah, this.
Yeah, this is a quiz I made you guys take.
So then.
So this should be the integral over the surface, right?
Should we do D area real fast or?
Yeah, we could do d area real fast. Let's think about d area real
It's
fast.
1, 0, 0, isn't it?
Yeah.
Yeah, so if I look at this thing, right? Where's the normal vector here? Positive x, right? So I'm going to get the integral of 2, 0, negative x, right? Dotted with a with I, right, with a unit vector, or unit normal, and then that result is going to be constant. You guys see that? So that's going to be the regular area, right? So I'm going to get what? I'm going to get 2 times the area of the square, which is,
Oh, just the area of the square, duh, it's 36.
so I'm going to also 72.
Would we, if we were being super correct, would we say that x is actually, the third component is actually 0 in that first vector? That negative x, because x is always 0 where we're at. I know it dots away and it doesn't matter.
No, that's a good point.
But
You guys see that? There are actually 2 reasons that the x doesn't matter, right? Because right here I've written curl of g, right? But what I really should have here is curl of g, right? Evaluated at your surface R. And on your surface R, the x is 0 anyway.
Oh,
You guys see that?
okay.
So yeah, that's actually a really good point. This should be 0 anyhow. Cool. Questions, Steele? Okay, cool. Thank you. That was a good catch.